This is a quick and comprehensive revision of topics ions, ionic bonding, and ionic compounds for Edexcel IGCSE Chemistry. So let's start with ions. Ions are formed when electrons are transferred, so they are charged particles. They can be either single atom like sodium ion with 1 plus charge, or can be formed of multiple atoms together or group of atoms like the nitrate with 1 minus charge. Atoms are trying to get to the full outer shell of electrons like noble gases because that will give them stability. So the complete or the full outer shell is a stable electronic structure. So metals tend to lose electrons from their outer shell and give you positively charged ion. Example of that is sodium. So this is sodium metal, sodium atom with the full electronic configuration drawn here, and it has only one electron in its outer shell because this is one of the elements in group 1, and it loses that electron in the outer shell, and then that will give you the metal, the sodium ion, which has 1 plus charge. It has 1 plus charge because now the number of protons inside the nucleus is 1 more than the number of electrons which orbit the nucleus. And then nonmetals, on the other hand, they tend to gain electrons in order to reach the full outer shell. They gain the electrons into their outer shell and they give you negatively charged ions. Example of that is chlorine. Chlorine is one of the group 7 elements. It has 7 electrons in its outer shell. It only needs 1 electron to reach the full outer shell, so it tends to gain 1 electron, and that will give you the chloride ion, which has negative 1 negative charge. This is because the number of electrons that orbit the nucleus is 1 more than the number of the protons inside the nucleus. Remember that you can find the type of atom and its charge from the periodic table. So group 1 elements will tend to form 1 plus ion because they have only 1 electron in their outer shell. Group 2 elements will give you 2 plus ions because they have 2 electrons in their outer shell and they will lose these 2 electrons. Group 3 elements will form 3 plus ions. Moving on to the non-metals, we have group 5 elements. They have 5 electrons in their outer shell. They need 3 more electrons to reach the full outer shell, so they form 3 minus ions. And then group 6 elements will form 2 minus ions. And finally, group 7 elements, which have 7 electrons, will only gain 1 electron to give you 1 minus ion. There are several other ions that you need to know their charge. They are not in any of these groups. So please, at the end of this slide, try to take a screenshot to memorize these ions and their charge. So let's start with silver. Silver is not in any of these groups, and silver will give you Ag plus 1 ions. And then we have copper. Copper has 2 plus ions. And then we have iron. There are 2 different ions for iron. There is iron 2, which has 2 plus ion, and then we have iron 3, which is the ion with 3 plus charge, and then we have lead, and lead has 2 plus charge. We have zinc, and zinc is Zn2 plus charge, and then we have the hydrogen ion with 1 plus, and then of course all the halogens will give you the 1 minus, whether we're talking about chlorine, bromine, or iodine, and the ion is called chloride, bromide, or iodide. Then let's talk about the ions which have group of atoms, like the hydroxide. The hydroxide is an OH and it has 1 minus charge. We have the ammonium ion. Ammonium is NH4 and it has 1 plus ion. We have the carbonate CO3 and it has 2 minus charge. And then the nitrate has, which is NO3, it has 1 minus charge. And finally, the sulfate, which is SO4, it has 2 minus charge. It's very important to memorize all of these ions and their charges. So let's move on to talk about ionic bonding. So when metals and nonmetals react together, the metal atom loses electrons. We know that metals tend to lose electrons to give positively charged ions, and the nonmetals tend to gain electrons to give negatively charged ions. So now we have oppositely charged ions with positive and negative charge, and these ions are strongly attracted to each other with electrostatic forces of attraction. These electrostatic forces of attraction is called ionic bonding. It's very important to know how to draw the dot and cross diagram for ionic compounds because they come a lot in your exam. So if we have something like sodium and chloride, sodium is a metal, chlorine is a non-metal. So sodium, when you draw the dot and cross diagram, remember that you need just to focus on the outer shell of electrons. You don't need to draw the inner shells. So sodium, the outer shell of electron for sodium has only one electron. So we draw the sodium with only one electron. In this case, we represent the electron in the outer shell of sodium with a dot. And then we have the chlorine. Chlorine is group 7. It has 7 electrons in its outer shell. So we draw the chlorine with its outer shell having 7 electrons. The electrons are now drawn as crosses. So you have distinguished between the electrons that come from both elements. And then sodium will lose the electrons to give a positively charged ion, and the chlorine will gain that electron to give you a negatively charged ion. Now we need to draw the ionic compound. So we draw the sodium that has lost the electron with no electrons in the outer shell with a positive charge, and then we draw the chlorine with the 8 electrons with a negative charge. Remember that you need to represent the electrons that moved from the sodium to the chlorine with the dot, and then leave the electrons that come originally from the chlorine as the cross. What about something like magnesium and oxygen? So magnesium is one of the group 2 elements and it has 2 electrons in its outer shell. It tends to lose these 2 electrons. Oxygen, on the other hand, is one of the group 6 elements and it has 6 electrons in its outer shell. It will gain 2 electrons. So magnesium now can lose these 2 electrons and give them to oxygen. So both of these will have a full outer shell of electrons. The ionic compound will be magnesium ion with 2 plus a charge, and then the oxygen with the 2 minus a charge. What if we have something like sodium, which has only 1 electron in its outer shell, with oxygen, which has 6 electrons in its outer shell? Sodium can lose only 1 electron to give 1 plus ion, while the oxygen needs 2 electrons to give you the 2 minus ion. So in this case, one sodium atom will not be enough to give the full outer shell for the oxygen. So we would need 2 of the sodium atoms to react with one oxygen. Here, in this case, each sodium atom will lose 1 electron to give it to the oxygen, and the oxygen will gain 2 electrons. So now to draw the ionic compound, we will have 2 sodium ions now, each with 1 plus charge, and then in the middle we're going to have the oxygen which has gained the 2 electrons, one from each sodium, and it will have 2 minus charge. How to name the ionic compounds? Ionic compounds are made up of positively charged ions and negatively charged ions. The positively charged ions mostly come from the metal ion, so the name will have the name of the metal. And then the negatively charged ion name will depend on whether it has oxygen or not. So if there is no oxygen in the non-metal or in the negatively charged ion, which could be group of ions as well, then the name will end with "ide", something like sodium chloride. There is no oxygen here. Remember that there is an exception for the oxides where the sodium oxide also ends with "ide" because there is only oxygen there. And the hydroxide, the OH, so we call the hydroxide when you have something like sodium hydroxide, we also end it with "ide". However, if we have more than one oxygen, then we will name it with the name will end with "ate", something like sodium nitrate. So the nitrate, the negatively charged ion will have NO3, will have three oxygens, so it's gonna called sodium nitrate, similar to that the carbonate and also the sulfate. What about the formula of ionic compounds? Ionic compounds made up of positively and negatively charged ions. The overall charge of an ionic compound has to be zero. So you need to balance the number of the negative charge and the number of the positive charge in order to have an ionic compound with a net of with a zero net charge. So if you have something like calcium, calcium is one of the group 2 elements and it forms 2 plus ions, and nitrate, we know that nitrate ion has 1 minus a charge. Now to form the ionic compound, it's going to be called calcium nitrate. The calcium itself, one ion of calcium will give you 2 plus charge, and then you need to balance that with 2 nitrate ion, each with 1 minus, so the total will be 2 minus now. So when you draw the structure of the calcium nitrate, you draw it like that: calcium, and then you open brackets and you put the nitrate, and then you put the number 2, which refers to the presence of 2 of the nitrate. What about something like ammonium sulfate? So you have ammonium ion, and we know that ammonium has 1 plus, and then the sulfate has 2 minus. So we would need, in this case, we would need 2 of the ammonium, so they can have 2 plus, and only 1 of the sulfate to have the 2 minus. So when you write the ammonium sulfate, you need to write it like this: ammonium and open brackets 2, because we need 2 of the ammonium, and then sulfate, just 1 of the sulfate, in order for the ionic compound or the compound to have a net charge of 0. So let's talk about ionic compounds. What about the structure of the ionic compound? It's very common for an exam, in your exam, to ask you about the structure of ionic compound. When they ask you about the structure of the ionic compound, you have to refer to the giant ionic lattice. So ionic compounds have a regular lattice structure called the giant ionic lattice. This is a very important expression that you have to use in your answer. And in this giant ionic lattice, the ions form a closely packed regular lattice arrangement, and there are very strong electrostatic interaction between the oppositely charged ions in all direction in this lattice. How does this affect the properties of the ionic compounds? Ionic compounds are solid at room temperature, and they have a very high melting point. Why do they have high melting point? They have high melting points because of the giant ionic lattice and the strong electrostatic interaction between the different ions in that giant ionic lattice. So they will need lots of energy to break that electrostatic interaction, or to break the ionic bonding, in order to melt ionic compounds. So it's very important in your answer to use these expressions: that they have giant ionic lattice, that they need, there are a strong electrostatic interaction, and also that they will need lots of energy to break these bonds. What about the other properties of ionic compounds? We have the electric conductivity. So in the solid state, ionic compounds do not conduct electricity because the ions are held in the giant ionic lattice. So there are no free ions to move, and they cannot carry charge. So no free ions to carry charge, because electric conductivity comes from either free electrons or free ions that can carry the charge. It's very important to use this expression: carry the charge, and use free ions. However, if you melt the ionic compound, then now the ions become a bit separated from each other. They become more freely moving. So now we have free ions that can carry the charge. Also, when you dissolve ionic compounds, the ions are separated and they are now free to move. So now we have free ions that are free to move, and they can carry the charge.